Hi everyone. Notes 1.7 are on applications of systems of equations. And this is part 3. And in this video, we're going to be talking about mixtures and percentages. And in order to be able to deal with percentages, we have to know how to write out percentages as decimals. So let's go ahead and talk about how to do that. So for starters, I'd like you to write yourself a note that percent is always out of 100. So for example, right here, we've got 7%. So to figure out what 7% is as a decimal, we would do 7 out of 100. And when I divide 7 by 100, I get 0.07. Because there are 2 zeros in 100, when I divide by 100, move this over 2 times, you get 0.07. 11%, 11 out of 100 is 0.11. 37% is 37 out of 100, so you get 0.37. And 156% is 156 out of 100, which is more than a whole. It would be 1.56 as a decimal. So in question number 1, it tells us that one type of granola is 30% fruit. So I'm going to write that down. I'm going to highlight that because that's important. And then another type is 15% fruit. And I want to know what mass of each type of granola should be mixed to make 600 grams of granola that is 21% fruit. So since we don't know the mass of the different types of granola, we need to write let statements for these masses. So we're going to say let the mass of the granola with 30% fruit to equal X, and then we'll let the mass of granola with 15% fruit will equal Y. So what this means is you have granola. In this granola right here, 30% is fruit, and then the other 70% is other types of food. And then in this one, 15% is fruit, and the other 85% is other types of things, other types of food in the granola. And we want to get 600 grams of granola altogether. That's 21% fruit. So we are going to mix a certain amount of the 30% fruit and a certain amount of the 15% fruit to get the 600 grams of granola, and that is 21% fruit. Okay? So we have 2 variables, so that means we're going to have to write 2 equations. Our first equation is nice and simple because we know that the mass of the first type of granola and the mass of the second type of granola have to add up to the total mass, which is 600 grams. The second equation is the tricky one right here. So for the second equation, we want to write an equation just for the fruit. So this is the equation for like the total. And then we're going to write an equation for the fruit. So for the fruit, we know that 30% of the first type is fruit. So I'm going to take 30% and multiply it by the first type of granola, the mass of the first type of granola. And we know the second type of granola is 15% fruit. And we know that altogether, 21% of the 600 grams of granola is fruit. So this fruit and this fruit together will equal the amount of fruit that we have. So we would say 0.21 times 600. And this right here is the fruit. Okay, so I'm going to rewrite these equations here. So I've got x plus y equals 600. And then over here, I've got 0.30x plus 0.15y. And that would equal 0.21 times 600. So I would have to multiply that 0.21 by 600. And I would get 126. Now that I've set up my equations, I can use substitution, elimination, whatever I prefer, in order to solve this. So I will use substitution this time just to change it up because I think the last time I made a video I used elimination. So I'll isolate the x. So to get the x alone, I'm going to subtract the y. So I get x equals 600 minus y. Now, don't forget that that's going to go into the other equation. So here, instead of x, I'm going to replace this x with 600 minus y. And then I'm going to add 0.15y, and that's going to equal 126. And now I can just go through and solve. So 0.3 times 600 would be 180, and then minus 0.3y plus 0.15y would equal 126. So put these two together, I would end up getting 180, minus This would give me 0.15y would equal 126. I'll bring this over here for the sake of space, and I'm going to subtract the 180 from both sides. So I get negative 0.15y would be equal to negative 54. Divide everything through by negative 0.15, and here I would end up getting 360. So now that I know that y is 360, I can go ahead and solve for x. So I'll solve for x in this equation right here because the x is already isolated. So x equals 600 minus 360 because that's what y is right here. So x would be equal to 240. Okay, and this is 240 grams and this is 360 grams. I can go ahead and write my therefore statement. So I'm going to zoom in right here and write it really small. I apologize if there isn't much room, but just try your best with it. There will be 360 grams of 30% fruit granola and 240 grams of 15% fruit granola. And that's it for this question right here, okay? So in question number 2, it says that Omar has a bottle of 50% isopropyl alcohol and realizes in order for it to be effective against bacteria and viruses, he needs a solution of 70% alcohol. Not wanting to waste the bottle he has, he finds a bottle of 91% alcohol and mixes it with the 50% alcohol. So I want to know how much of each solution should he use to make 250 milliliters of 70% isopropyl alcohol. So in order to be able to do this, I need to ask myself, what are the things I don't know? Well, I don't know how much of the 50% alcohol I need and how much of the 91% alcohol. So what we're going to do here is we're going to say, let the volume, and again, you probably will want to write small for this question right here, of 50% alcohol. We'll call this A, just to switch it up. And then let the volume of 91% alcohol, we'll call that B. Again, just to switch it up a little bit. We have two variables, so that means we have to write two equations. So first of all, let's do our easy equation right here. We know that altogether, there's 250 milliliters. So the volume of 50% alcohol plus the volume of 91% alcohol has to equal 205 milliliters. So this one right here is the total. This is the equation for the total. But then if you take, so what this means again, 50% alcohol means that in the mixture that we have here, 50% is alcohol, the other 50% is water. 91% alcohol means that 91% of it is alcohol, 9% of it is water. So in a mixture of 205 milliliters, we want 70% of that 205 milliliters to be alcohol. So that means that we want this total to be 70% of 205, because this equation right here is just for the amount of alcohol, okay? And for mixture A, 50% of that is alcohol, and for mixture B, 91% of that is alcohol. And that all together will equal this 70% of 205. Okay, so same thing that I did before. I'm going to just rewrite my equations down here. So A plus B equals 205. And then here, I'm going to say 0.5A. And again, and you can say 0.5 instead of 0.50. It means the same thing. Plus 0.91B will equal 0.7 times 205. So I'm going to do this multiplication right here. And I get 143.5. Okay, now this time what I'm going to do is I'm going to use elimination just to change things up a little bit. So I'm going to eliminate the A's. So I'm going to multiply the top equation by 0.5, but I'm going to multiply it by a negative to have the signs be the opposite. So when I multiply that through right here, let me just draw a line here. I end up getting negative 0.5A minus 0.5B is going to equal 102.5. And that should be a negative, okay? Negative 102.5. And then I'm just going to copy the orange one down right here because now my coefficients will match up but be opposite signs, which means that the a's will be able to cancel. And then I can just add my two equations together. So when I add my equations together, the a's cancel. I get 0.41b, and here I end up getting 41. So then divide both sides by 0.41, and B is equal to 100 milliliters. Now that I know what B is, I can replace that in the equation A plus B equals 205. So here I can say A plus 100 would be equal to 205. Solving for A, I would get A equals 105. Okay, so this right here, these are my two amounts. So we can write our therefore statement right here, and we can say, therefore, he needs 100 milliliters of 50% alcohol and 105 milliliters of 91% alcohol. And this answer should make sense to you because right here, 70% alcohol is pretty much the average of 91% and 50%. So we should have a pretty even split, but we need a little bit more of the 91% alcohol for the 205 milliliters to make that 70% alcohol. And if you notice right here, it's almost an even split, 100 versus 105. All right, people, in our last example, we're told that a candy store is preparing a mixture of chocolate raisins and chocolate peanuts. The raisins sell for $2.22 per kilogram, and the peanuts sell for $1.75 per kilogram. So how many of each type must be mixed? And sorry, this is spelled out incorrectly, to make 20 kilograms of a mixture that will sell for $41. So this time in this question, the two things that we don't know is how much, what the weight of the chocolate raisins would be and what the weight of the chocolate peanuts would be. So let's go ahead and write out our let statements for that. So the mass of the chocolate raisins would be X, and we can say the mass of the chocolate peanuts would be Y. Okay. We still have a total amount of 20 kilograms. So I'm still going to say X plus Y would equal 20 because this right here is the total amount that we are dealing with. Okay. But this is where things get a little bit different. It's 222 per kilogram for the raisins. So I'm going to say 222X. And it's $1.75 per kilogram for the peanuts. So I'm going to do $1.75 times Y. And that altogether is how much I am paying for the total amount. So this right here would be $41. I don't multiply 41 by 20 kilograms because this is not $41 per kilogram. This is the total amount that you're going to pay after you pay per kilogram for each type of candy. And right here, I'm just going to add on right here that this is the total mass. And then this right here, I'm going to just put down here that this is the total cost. So once I do that, I can go ahead and set up my equations right here and decide if I want to use substitution or elimination. And I'll use elimination again. But this time I'm going to eliminate the y's. So that means I'm going to multiply this top equation right here by negative 1.75. So when I do that, I get negative 1.75x minus 1.75y, and that right there would be equal to negative 35. And then I can just copy down the other equation right here. So here I would get 222x plus $1.75y would equal 41. So when I put these together, the y's cancel, and I can go ahead and put these two terms together, and I get 0.47x, and that would equal, when I combine negative 35 and 41 together, that would equal 6. Now divide both sides by 0.47 and x would equal 12 point, this doesn't work out perfectly, we'll say 12.77 kilograms. So now that we know what x is, we can just replace that in one of our equations. I'm going to use the top one because it's much simpler. So I get 12.77 plus y is equal to 20. And then I can just subtract the 12.77 from that, and I end up getting 7.23. Let's go ahead and write our therefore statement. So therefore, the mass of the raisins is 12.77 kilograms, and the mass of the peanuts is 7.23 kilograms. And we are done with this question. And that's it for this video. If you have any questions, let me know. Otherwise, I'll see you around. Have a great day. Bye.